Welcome everybody to the ISC Supermicro Exhibitor forum presentation, this year in the digital version. My name is Martin Galle, Field Application Engineer at Supermicro. The topic of the talk today is the presentation of Supermicro's GPU server portfolio. New technologies have been launched very recently, and as always, we are among the first adopters and enablers of those technologies. Driven by curiosity, mankind has always been trying to understand and, as accurate as possible, explain the phenomena that can be observed in nature. Johann Wolfgang Goethe, the famous German writer, who has lived in Weimar but also for many years here in Frankfurt, has made his character Heinrich Faust express this in the well-known sentence. The understanding of the fundamentals of matter and the complex processes during the early evaluation of the universe is one of the most challenging topics in astrophysics. According to recent theories, so-called quark-gluon plasma filled the entire universe for a short period of time after the Big Bang. In a later stage, when density and temperature decreased, so-called hadrons, better known as neutrons and protons, were formed from this quark-gluon plasma. This is making quark-gluon plasma very interesting for the scientists. Quark-gluon plasma can be generated artificially, for example in the Large Hadron Collider at CERN, by accelerating heavy nuclei to almost speed of light and making them collide. But there is no evidence so far, by observation, that quark-gluon plasma is existing at larger scale in the universe. Detecting and proving the existence of quark-gluon plasma in the universe would strengthen many theories and greatly enhance the general understanding of the fundamentals of matter. According to modern particle physics, matter inside merging neutron stars is so dense and hot that it could be dissolved into its elementary particles, quarks and gluons, and thus form quark-gluon plasma. Leading-edge research carried out at the Goethe University in Frankfurt, and now we are coming back to Mr. Goethe, is focusing on the analysis of this process with the help of simulations. This video sequence actually shows the result of the simulation of two merging neutron stars. The emitted material that can be seen here also contains heavy elements, and depending on their masses, the merged neutron stars might form a black hole after the merge. These simulations predict that the phase transition from neutrons and protons to quark-gluon plasma will impact the characteristics of the gravitational waves emitted from the merging stars. Let's have a closer look on gravitational waves. According to Einstein's general theory of relativity, nothing can be faster than the speed of light, including the gravitational forces between massive objects, and therefore changes in gravitational fields must be propagated in form of waves. One challenge is that gravitational waves are extremely hard to detect, and they have been only existing in theory until a few years ago. The first wave was detected in the LIGO experiment. Until today, only a very few waves have been observed. However, in case the special patterns of the phase transition between hadrons and quark to quark-gluon plasma can be found in gravitational waves, this will prove the formation and existence of quark-gluon plasma in nature. The described processes of simulating the neutron-star merge can be supported by GPUs. The computational power of GPU-accelerated HPC cluster can be used to carry out the hydromechanical simulations. Furthermore, artificial intelligence can help to detect gravitational waves and the special patterns in the signals. AI typically consists of a training and inference steps. Those parts, HPC, artificial intelligence training and inference, have different hardware requirements. For example, typical bottleneck in HPC is the bandwidth between GPU and host memory. Artificial intelligence training requires a very fast communication network between the GPUs, and artificial intelligence inference performance mainly depends on the GPU performance for integer and floating point operations with reduced accuracy. So let's have a look now at the Supermicro GPU server portfolio. Supermicro actually has the largest portfolio of GPU optimized servers in the industry. Therefore, it is possible to easily find the best matching server for each task. Furthermore, we are the earliest adopters of new technologies, resulting in leading-edge, high-technology products. This slide gives an overview of the GPU-optimized server portfolio. GPU-optimized means that those servers are developed and optimized in terms of cooling and power in order to host CPUs and GPUs. There are servers ranging from single CPU plus 2 GPU up to dual CPU servers with 16 GPUs. Let me focus on the most important models in the next slides. The first server I want to present here is the 4029GP, which is a 4U server with 2 Intel Cascade Lake CPUs. This server can host up to 10 double-width PCIe GPUs. There are two models with different PCI subsystems. The Dash TRT model has one PCI switch connected to each CPU, which results in a much better memory bandwidth between GPU and host memory. This is a typical requirement for HPC workloads. The Dash TRT2 model has both PCI switches connected to a single root under the same CPU, which allows a faster GPU to GPU communication because the data does not need to be transferred via the CPU to CPU UPI link. Fast GPU to GPU communication is essential for artificial intelligence training workloads. This server, the 6049GP, is also a 4U server with 2 Intel Cascade Lake CPUs. The PCI subsystem of this server consists of 4 switches with 96 lanes each, so it is possible to host up to 20 single-width GPUs in this chassis, each of these GPUs connected via 16 PCI Express lanes. The typical workload for this kind of server is artificial intelligence inference. The Supermicro GPU server portfolio also includes several products supporting the NVIDIA NVLink technology. The smallest server, which can support up to 4 SXM V100 GPUs, is the 1029GQ. It is a 1U server with dual Cascade Lake CPUs, and because of the NVLink technology with up to 300 GB per second GPU to GPU interconnect, this server is perfectly suited for smaller artificial intelligence training, but also high-performance computing and data science workloads. The next larger model, the 4029GP, is also based on the NVLink technology. This 4U server can also be equipped with dual Cascade Lake CPUs and up to 8 SXM V100 GPUs. This system is frequently used for mid-size artificial intelligence training, big data analytics, but also for high-performance computing workloads. The top model in our GPU server portfolio supporting the SXM3 technology generation is the 9029GP. This 10U server can host up to 16 V100 SXM3 GPUs, which are connected via NV switch technology. This server is actually very much comparable to the HGX2, but it can be easily customized on component level like CPU, memory, and drive. Another very important feature are the additional 16 PCIe X16 slots, generation 3, which allow for the installation of one RDMA network card per GPU with up to 100 gigabit per second usable bandwidth. All the systems presented so far are supporting PCI Generation 3 technology. In the following section, I will highlight our new generation of GPU systems based on AMD Rome CPU. Rome CPU already support PCI Express Generation 4, therefore these servers can fully exploit the latest developments in GPU technologies. The first system I would like to present in this section is our 4124GS. This is a 4U server designed to accommodate up to 10 double-width GPUs. The motherboard in this server is a dual processor motherboard hosting 2 AMD Rome CPUs, and the server provides either 8 PCI Express X16 plus 3 PCI Express X8 slots or 10 PCI Express X16 slots. All PCI Express slots are generation 4. And the very special feature of this system is that even in case of the 10 times X16 slots, there is no PCI Express switch on this system. And this has been made feasible by a special design of the board, that we are not using 64 lanes to connect the two CPUs together, but only 48. The remaining lanes are used to provide the 10 PCI Express X16 slots. So we can directly connect each GPU to the CPU by the full PCI Express bandwidth, and each GPU can access the host memory with a high bandwidth. This makes the server very well suited for all HPC workloads. The server can be equipped either with up to 10 double-width GPUs or with 8 GPUs plus 2 network cards. So each set of 4 GPUs could have its own network card for RDMA. Network card also can be installed in the X16 generation 4 slot. That means the server supports with 8 GPUs additionally 2 200 gigabit network cards. The next system is the 2124 GQ. It's a more or less direct successor of the 4 GPU NVLink system, which I presented earlier. In this case, the system has 2 height units. The motherboard is also a dual processor AMD Rome CPU motherboard, and consequently the supported generation in PCI Express is generation 4. This system can host the NVIDIA Redstone technology, connecting 4 A100 SXM4 GPUs with NVLink. And this NVLink is the latest generation, SXM4, with up to 600 gigabyte per second bandwidth. So this system with a fast interconnect between the GPUs is very well suited for artificial intelligence training, but of course also for high performance computing and other workloads. Finally, let me present another very interesting system. This is a Supermicro GPU blade system. The blade system consists of an enclosure. In this case, it's an 8U enclosure, and each enclosure can include up to 20 blade systems. Each blade is actually one complete compute node. Each blade is equipped with one AMD Rome CPU and can also carry either 2 single-width GPUs or 1 double-width GPU. And this actually results in the same GPU density of 2.5 GPUs per height unit as for the 4U 10 GPU systems which I've presented earlier. Additionally, there are 2.5 Rome CPUs per height unit plus all the necessary network equipment like gigabit network or InfiniBand network if necessary. Everything is included in this 8 height unit enclosure. The typical workload for these high-density systems are enterprise applications, content delivery, or HPC hosting workloads. But there are many more use cases this system is perfectly suited for. And this is actually what I would like you to take away from this presentation. Supermicro has the largest GPU server portfolio in the market. Supermicro has optimized server for each task and workload, and we also carry servers with crossover functionalities that can be used for more than one task or workload. After we have seen many different GPU systems, this table gives you an overview which platform is suited for which workload and can help you to identify the best configuration. But I don't want to go into detail here. Instead, I will focus on the tasks which we discussed earlier with regards to the scientific challenge. For the detection of quark gluon plasma challenge, we had already identified 3 dominating tasks: HPC, artificial intelligence training, and artificial intelligence inference. The diagram on the left-hand side shows the normalized price-performance ratio of different systems for double precision, the yellow bars, and reduced precision, the green bars, operations. Obviously, the new A100 platform delivers the higher double precision performance, while the system with the 20 times T4 gives you the best performance per dollar for the reduced precision operations and integer operations. In the right diagram, you can see the comparison of GPU to host memory and GPU to GPU memory bandwidth. For GPU to host memory bandwidth, the best setup is of course to have one dedicated PCI link per GPU. And here PCI generation 4 is better than PCI generation 3 by a factor of 2. Regarding the GPU to GPU bandwidth, it is no surprise that the NVLink of second generation is 10 times and the NVLink of third generation is 20 times faster than the PCI generation 3. If you take a look at those numbers, the best platform for HPC is obviously the 8 times A100 server with direct PCI generation 4 link to the GPUs. It delivers highest double precision performance and the best GPU to host memory bandwidth. For the artificial intelligence training, GPU to GPU bandwidth and floating point performance are decisive. So any of the NVLink systems would be a good choice, maybe with a small advantage for the A100 system. Finally, for artificial intelligence inference, you should go for the best reduced floating point or integer performance. So the best suited platform would be the 6049 with 20 times T4. So the Supermicro GPU server portfolio allows you to pick the best suited platform for each of the tasks. In case you have additional questions, please feel free to contact me or any other Supermicro representative. Thank you for listening. Stay safe and goodbye.
Learn more at supermicro.com, powered by Intel.